All right, today we're going to be talking about solving simultaneous linear equations in two variables using the graphical model. So up until now, we've only talked about one equation at a time. Now we're going to consider two linear equations, or simultaneous linear equations, working together. When we have two or more equations working together, we also sometimes call them a system. So you'll also hear me say a system of linear equations. And that just indicates to you that they're working together, they're part of the same problem. Whenever we have two or more equations in a system, we still need to find a solution. Their solution is going to be whatever answer works for both of them. So we are looking for a common solution. So one solution that works for both or all of the problems, because sometimes you can get, let's say, three equations together. So please make sure that you have this in your notes. So one solution that works for all equations. That's all that is. Because normally when we have one equation, we're looking for a solution that works for that equation. But now if we have two or more, we're looking for one solution that can work for all of the equations. So we're still going to come up with an x value and a y value written as an ordered pair. Okay? Just one that has a common solution. All right. Let's take a look at this one as an example. So the equations, the system was x plus y equals 6 and x minus 2y equals 3. So we have both of the equations already plotted out for you. We have x plus y equals 6 in red. And we have the x minus 2y equals 3 plotted out for you in blue. You'll notice they intersect at a point. And all along those lines, we see solutions that work for them. Here's another one. For the blue one, we have this point right here, this point right here, and this point right here. Okay? So let's go ahead and check these points. Let's look at this point for x plus y equals 6. It is 2, 4. Let's plug that into x plus y equals 6. If x was equal to 2 and y was equal to 4, it would become 2 plus 4 equals 6. Does that work? Yes, it gets you 6 equals 6. Correct. Now let's take a look at this point right here that is shared by the blue line, x minus 2y equals 3. It is at point 5, 1. Let's plug that in here. Remember, this is x and this is y. So it becomes, instead of x plus y, it's 5 plus 1 equals 6. 5 plus 1 is equal to 6. 6 equals 6. True. Okay? Now I'm going to move to my blue line, x minus 2y equals 3. I'm going to plug in this point right here, 1, 1. It's a perfect one to plug in. Instead of x, I put 1. Instead of minus 2 times y, I put minus 2 times 1 equals 3. PEMDAS says I need to do my multiplication first, so this is 1 minus 2 times 1 is 2. Oh, sorry, that's negative 1. 1 negative 1. No wonder it didn't work. 1 negative 1. I was like, wait a minute. Okay, 2 times negative 1 is, negative 2 times negative 1 is positive 2. So 1 plus 2 equals 3. There was a mistake. Okay, so now it works, okay, because I have the correct points in there. And then remember, these two lines intersect at 5, 1. They both share 5, 1. Let's double check and make sure 5, 1 works for that one as well. We have x minus 2y equals 3. Instead of x, I have 5 minus 2 times my y value is 1, a positive 1, equals 3. I solve my multiplication first. 2 times 1 is 2, so it's minus 2. And 5 minus 2 is equal to 3. Yes, so if you notice, the points on the line work, and they both share 5, 1 as well. So 5, 1 works for both of them. That is their common solution. So the solution for this problem is not all these numbers, 2, 4, 5, 1, and 1, negative 1. The solution for this problem is 5, 1. One solution. Remember, because we're looking for a solution that works for both equations. All right. This was the same thing that we just did. Let's take a look at this next problem right here. Solve using the graphical model the simultaneous equations, or the system of equations, 6x plus 9y equals 1 and x plus y equals 1. So go ahead and pause the video. You're going to just choose random points. Like you can, usually people like to start off with a negative number, up 0, and a positive number, okay? Or you could choose negative 1, 0, and 1 or something, okay? Because ones are easy to plug in. So go ahead and pause the video, plug in some x values for each of them to figure out the y values, and then graph. All right. So you should have gotten a graph that looks like this. They decided to choose negative 2, 0, and 2 for the first equation, 6x plus 9y equals 1, and negative 3, 0, and 3 for the second equation. You didn't have to choose the same x values, but you should, once you graph it, get two lines that intersect kind of in this area right here, this second quadrant right here, where all the values, the y values are negative and the x values are positive. Okay? If you notice for the first equation, it's not very pretty. You're gonna get some decimals. And they said that they rounded it off to the nearest hundredths place, the 2 decimal places, because beyond that there's really no point. But you do kind of need to know where you're plotting, and then you kind of have to estimate where that ordered pair is. So if yours doesn't look quite like this, that's okay, but it needs to look similarly to this, okay? And then we see that it's intersecting at this point, which is pretty ugly. Doesn't have whole numbers in its answer, so it's going to be a fraction or decimal. We don't like that, but it is the problem, okay? Even though we don't like it, it is what it is. Now we wanted to show you this example because the actual answer here is 8/3. I don't like that they didn't change it to a whole number or a mixed number, and negative 5/3. Because like we said in class, this format, this improper fraction format, doesn't help me. I still have to change it to a mixed number in order to read it on the graph, right? Because I can't read improper fractions on a graph. So this is really 2 and 2/3 and negative 1 and 2/3. Okay, so 2, if we were to block this into thirds, this would be 2 and 2/3 right here, and then negative 1 and 2/3 would be kind of over here ish, okay? Because this is negative 1 and 1/3, and then negative 1 and 2/3, those dashed lines. This would be 2 and 1/3 and 2 and 2/3, those dashes. Okay, so the point of this problem is to show you that the graphing method is not always the best when you have fractions, as we saw before. So algebraic method that we said in that previous video is still the best way because we can get our fractions clearly. Here we're kind of estimating. Okay, go ahead and try this problem now. Example 7. Solve using the graphical method the simultaneous equations x plus 2y equals 4 and 2x plus 4y equals 5. So same as before, create a table, make up your own x values. Again, you can have a negative 1, positive 1, and 0. That's a good place to start. So you cover everything on your coordinate plane. And then do that for both equations so that you can get at least 3 coordinate pairs to draw lines through. All right, you should have gotten a graph that looks like this. If you were thrown off, that's okay. They're supposed to look like that. And you didn't have to choose the same points. As long as you ended up connecting your lines and you got 2 lines, 2 parallel lines that never meet. If you do get parallel lines that never meet, that means that you have no solution because they never intersect. So there's no solution. That's the answer here. Remember, we have a solution when they do meet up, and then we figure out what that point is. That's our solution, right? But these 2 lines never meet, so there's no solution. They're parallel lines.